Thank you for joining us for the U.S. Drought Monitor listening session today. This webinar will give you a look into how the U.S. Drought Monitor is developed each week and give you some insight on how you can contribute to that process. Dr. Deborah Bathke will lead your session today. She is a climatologist, the Education and Outreach Coordinator, and one of the U.S. Drought Monitor authors at the National Drought Mitigation Center. So if everybody would just stay muted during the presentation, that would be great. We will have about a 30-minute presentation, and then we'll open it up for questions. So you can type questions in the chat box at any time when you think of them, and I will go through those once Deborah's done presenting. Anyway, we'll go ahead and start. Thank you for joining us. Go ahead, Deb.
Thanks, everyone, and good afternoon. I'm going to attempt to share my screen. You think I would have this figured out by now, but using multiple screens always kind of confuses it. Of course. Are you seeing what you're supposed to?
Yep.
If at any time you can't hear me, just go ahead and put something in the chat box and Tanya will yell at me to speak up. And let's go ahead and get started. So the U.S. Drought Monitor. Be talking about a few different things, as Tanya said. So what's on the map, what do the different colors mean, and then how is it made? And that includes the part about how individuals can contribute to the process. This is, okay. I got that down. So we'll start out with the most recent map that was released this morning. This map shows where drought is occurring, its spatial extent and severity, and the timescale of the associated impacts or the consequences of the drought. It sounds easy, right? So to understand the map, we first need to understand drought. In its most basic sense, drought can be defined as a deficit of expected water availability that results in water shortages for some activity or group. That seems simple enough until we stop and think about it for a minute. So first, the amount of moisture that we expect varies depending on where you live and the time of year. So for example, the amount of water that you expect to get through rain and snow is different in the eastern part of the US than it is in the desert Southwest. And the amount that you expect also depends on the time of the year. So in the Southwest, we're starting to head into that summer monsoon season. So they should be getting a little bit more precipitation as that starts up. And then once we looked at the need component of it, the amount of water that is needed depends on the group and also on the time of year. So for example, when agriculture needs water and needs that moisture is different than, say, when tourism, such as the ski industry, needs it. So with the U.S. Drought Monitor and that single map, we try and capture all of these different perspectives of drought. At least that's what I like to call them. So drought means different things to different people. These perspectives are meteorological drought, so based on just the actual amount of rain and the weather conditions. You might look at it through the perspective of an agricultural producer and when you need the precipitation, or from a water supply or hydrological perspective, or for the natural environment or the ecosystem, or socioeconomic in terms of the goods and services that are affected by drought. Oops. So all of this is captured onto one map. And why do we try and put all 5 of these different perspectives on one map? Because in the very beginning, when the Drought Monitor was in its concept phase in the late 90s, that's what policymakers wanted. They wanted one simple map that showed an overall picture of what drought conditions looked like across the entire United States. So to capture these different perspectives of drought, we look at water availability at different points in the water cycle to try and capture a comprehensive or as comprehensive picture of drought as we can. Basically, how is drought affecting the system as a whole? So precipitation or rain and snow are only one part of the map. We take into account the effect that the lack of precipitation is having on soil, on surface and groundwater, and plants. We also look at the demand from the atmosphere through evaporation and evapotranspiration. And we only have to look at the temperatures that the heat wave that we've been having over the last week or so, as it's kind of moved across the country, to notice that that has an effect. The last thing I was saying was, I do want to point out that we don't have measurements for all of these different parameters at all locations and at all time scales. Because the U.S. Drought Monitor strives to show both short and long-term drought, we look at measurements across different time scales. So anywhere from what happened during a single storm and how its effect, and look at what happened during a single storm and its effect, or in cases like where we have really long-term drought, we might look at data over multiple years. So for the West, places like in the West. I lost my groove, so sorry, get back into it. That's okay. So in the next few minutes, we're going to break down the map. When you look at the map, the first thing that you probably notice is the color. These colors represent the intensity of the drought, with the warmer colors or the darker colors indicating more severe conditions. D0, which is indicated by yellow, represents area where it is abnormally dry, statistically speaking, and those areas aren't technically considered drought. Instead, that yellow color D0 is used to show areas that may be heading into drought or still suffering some lingering impacts as they're coming out of drought. So that leaves us with 4 categories of drought, ranging from moderate drought, which is the beige color, to exceptional drought, or D4, which is the brick red color. And then the white represents normal to wet conditions. As I've already said, the map depicts time scales of drought conditions. So an S that you see over parts of the eastern US represents drought that has been present on timescales of about 6 months or less. When we have drought, shorter term drought, you generally see impacts to agriculture or grasslands. When you see an L, which is over parts of the Pacific Northwest and the Texas and Oklahoma panhandles, that represents conditions that have been present for longer than 6 months. So you might be starting to make up some of those, you might be starting to make up some precipitation deficits. You might be having some kind of normal conditions, but when we look at longer time scales, they're still there. And then the final thing that you see is an S and an L together. And we see that over Nebraska, which is where we are here, and Montana, other parts of the West, also over Louisiana, and along the East Coast as well. And that SL stands for both short and long-term conditions, meaning that while we've had drought conditions present for longer than 6 months, we're also continuing to see current moisture deficits kind of superimposed on those long-term deficits. The heavy black lines that you see kind of over the West Coast and again over the Texas, Oklahoma area, we use those to kind of delineate or to separate or mark areas where we have different types of drought right next to each other. And then the last component that I want to talk about is each week the author writes a narrative that explains any changes that they made to the map this week. And that narrative is broken down into a national summary and then also by each climate region. So Northeast, Southeast, South, High Plains, Midwest, and West. And what the authors do in this is they'll talk about some of the, they'll mention some of the specific products that they use to help make that determination or the time scales. And I will show some maps of this in a little bit to give you a better idea of what I mean here. And then with that narrative explaining any changes, you can also pull up a change map. And this is showing the difference in the map between this week and last week's map. So yellow indicates where we've had a 1 category worsening of conditions. And then the green, the light green is where we've had some improvements in conditions. And we can put those links in the chat box for you near the end. So now let's move on to what does all of that mean and how do we determine the different colors that are on the map? So drought categories, how do we assign the drought categories? We start by looking at all of these different types of data. So data at different time scales, data at different points of the water cycle, and all of the data is put into percentiles. Percentiles tell us the historical likelihood that conditions will occur. So for example, an exceptional drought indicated by the darkest brick red or maroon color on the map is a type of drought that we'd expect to see once or twice every 100 years. And normally dry conditions, those are conditions that we'd expect to see once every 3 to 5 years. So what do we mean by percentiles? So to determine percentiles, we start with a data time series. In this case, I'm showing annual precipitation. And for whatever length of period we have, for this example, I'm showing about 100 years because that makes it easier to talk about percentiles. And so if we look at this data set, we can see that, you know, rainfall's variable. It ranges from, let's see, the lowest ever was 7.97 in 2020. The highest was 34.53 inches in 1941. So to calculate, oops, I've got more on there. To calculate percentiles, the data is ranked from largest to smallest. So we see that 34.53 inches were the most, and that occurred in 1941, and then that 7.97 in the least. The exceptional drought is the first and second percentile. So that of that 100 years, it occupies those lowest 2 positions. So if you see drought that is on the map that's showing up as that kind of dark red brick color, you know that conditions are among the worst that we have over the entire period of record. Extreme drought occupies ranks 3 through 5, and severe drought 6 through 10, And then 11 to 20 is moderate drought, and 21 to 30 is abnormally dry conditions. So based on statistics. So for color to show up on the map, conditions have to rank in that bottom 30 out of 100 years of data. Some of the advantages of using this method is that percentiles can be applied to any parameter. They can be used for any length of record, and they help put drought into historical perspective. When I think of percentiles, I've got, and so does Tanya, we both have elementary school age children, and as your kids are growing, they talk about percentiles a lot. So my kids in the 85th percentile or 87th percentile for height. So that means out of 100 kids, there are only 13 that are taller than him. So when we look at precipitation percentiles, it's kind of the same thing. If we're in this first or second percentile, that means 98% or 98 kids are out of 198% of the data has a higher amount of precipitation than what we're looking at right now. So how do we make the map? I like to think about the map as a participatory process where we have involvement from different groups of people at different levels. So the very first thing that I would like to point out is that the map is a partnership among the National Drought Mitigation Center, the U.S. Department of Agriculture, and NOAA, the National Oceanic and Atmospheric Administration. So these partners collaborate on the map standards and the methodology. So the decision to use percentiles, that was a decision based on these three groups. The decision for the color scheme was a decision that these three organizations came to. Everything about the map is a partnership. It's not made by one entity alone. Currently, we have 9 authors for the map. This shows the location. We have 3 of us here in Lincoln at the National Drought Mitigation Center. We also have an author at the Desert Research Institute in Nevada and National Centers for Environmental Information in North Carolina. And then we have the Climate Prediction Center and USDA in the DC area where we have authors as well. The requirement for authorship is that the individual must work at a national or regional center. The Desert Research Institute, it's the Desert Research Institute and the Western Regional Climate Center. I suppose I should update my figure. So that's a regional center. The 2-week, each author typically does a 2-week shift. And that's broken down into 2 separate weekly cycles. Deadlines are pretty much set in stone with the map released on Thursday. The only time that's affected is if you have Thanksgiving or Christmas or some other federal holiday that falls on a map release date. Like most things in science, the U.S. Drought Monitor doesn't follow a step-by-step approach or recipe for creating the map. We don't have a prescribed or set weight for each type of input. So the different things that we look at, the data, the impacts, and even the subjective or local expertise is interpreted and weighed by that map's author that week. Typically, we start with looking at objective data. So that's the data from rain gauges or from snow measurements or from stream flow. All of that data is put into a geographic information system so that we can turn layers on and off to quickly, or at least fairly quickly, look to see what different data are showing at different timescales. We also look at impact reports that come in. The impacts help tell the story of the drought. And we use that initial information to create a draft map that we send out to a listserv that I think I heard is over 500 people on that listserv now. And so we send the draft map out to them. They oftentimes, the people on that listserv, have their own networks of people that they get feedback from. They send that back to us. We release another drought map or draft map. And finally, we release that final map on Thursday morning. So this is almost 2 years old. So I need to get an updated version of this. This is that listserv that the draft maps go out to. At this time, it had 451 people on there. And again, it's not really reflected of the number of people who probably see the map, because oftentimes in a state, they'll have their own network of people who aren't on the listserv, but they do provide feedback. And so now I'm going to kind of take you through a process. Like I said, we don't have a set process set in stone, but I think all of the authors approach things, basically the same way. And so these maps that I'm going to show you, they're available every week on the Drought Monitor's homepage under current conditions. So I've got the link here. I'll put it in the chat box later on. So what I think almost all of us do is we start by looking at where it rained and where it didn't rain. And because it's in a geographic information system, we can take the lines from the previous week maps, turn off the shading, and then lay those right on top of the estimates of rainfall. And in this case, it's AHAP's 7-day precipitation. So it's over the 7 days since the last map was released, or since the data cutoff period. And it's the AHAPs just means that it's a multi-sensor precipitation estimate that incorporates both radar and rain gauge data. And this is produced by the National Weather Service. So I want you can either look at your own location. And in this case, I drew a circle around Montana because that's one place that I remember where the map showed that there were some improvements made this week. So here we're looking at, we can see that in the last 7 days, they had anywhere from 2 to 6 inches of rain in that area. And then we might look at, well, how did that rainfall affect stream flow in the area? Here, it's as you would expect, the kind of bluish cool colors represents wet conditions. The yellows and the reds and the warmer colors represent dry conditions. Most of the stream flow in the area looks pretty good. Then we start to look at a variety of different drought indices. Drought indices they just use math to help put the data into a historical context. And so this particular one is called the Standardized Precipitation Index. It only uses precipitation. And when we look at that over a month, we see some dryness there and some normal conditions. So that's what it's telling us at 1 month. If we look at 3 months, we can see that, so we're looking for ending the prior 3 months ending on that day's date as of Tuesday. We can see some D3 conditions, some red, a little bit of D4 there, and then over kind of on the eastern part of that area, we see some near normal conditions at 3 months. So at 3 months, the normal means they're not having any precipitation deficits. If we go out to the water year to date, so from October 1st, that's what is used in the West a lot of times, we can see that there's still in that eastern part of that area, conditions are a little bit better. We don't just look at data from one source. So this is still precipitation data, And this is still the standardized precipitation index, but it's based on a different source of data. This includes radar estimates as well. So not only different types of data, but the same data from different sources. And this is showing us the same, the same picture there, that it's a little bit better in the eastern half of that drought area than the western half. We look at, and all of these, we look at different time scales. This particular one is looking, it's called EDDI. It's looking at the evaporative demand, or the thirst of the atmosphere. So this is something that when we have high temperatures and windy conditions, you can see more drying out, because the atmosphere is really dry and it wants to suck up any moisture from the surface. So that's another product that we look at. We can look at how is that dry atmosphere affecting how is that affecting evaporation? And that's what this index shows us. It's estimating how much is evaporated from the surface. And another thing that we look at would be, what is the impact of that on vegetation? So how do those warm conditions, how does temperature affect vegetation? How does a lack of precipitation affect vegetation? And this index shows how it affects fire danger. And all of these maps use about the same color scheme to help make it easier for us to compare. And another example is we look at this is showing a NASA-based satellite estimate of soil moisture, but we have other estimates of soil moisture that we look at too. And this one is showing us that surface soil moisture is wet or normal. And if we go down deeper to root zone, it's not quite as wet as it is. And I didn't pull up the next one, but I'm guessing that would probably show drier, because it takes a while for that precipitation to percolate down to those deeper levels. All we look at over 150 maps. I think this was a sample of maybe 12 maps that we look at. Once the author kind of does an initial overview and goes through all of those maps, we create a draft. Sometimes authors will send out anywhere from 1 to, I can't remember the most I've ever seen. I think the most I've ever done personally is 4 drafts and then the final map. But we send that out to the listserv, and each draft that is sent out includes an explanation by state of any changes that were made to the previous week's map or the earlier draft. So that when it goes out to those listservs, they can find their state and they can find what changes were made in their area and why, what the author was thinking, what data they were maybe have weighted more heavily than other types of data. Once that draft map goes out, the feedback starts coming in. And this is just an example from South Dakota. So they sent in some feedback and they said, we've coordinated with our neighboring states of Minnesota, Iowa, and Wyoming on this depiction. They gave their justification. We leaned heavily on 30 to 90 day station-based precipitation, that evaporative demand, drought index, soil moisture, stream gauges, and impact reports from extension. So they also include what they're looking at to make their depiction of it. And it really is a back and forth, or a virtual, sometimes it's over the phone or a webinar conversation. And so this is just showing that this was their recommendation. And I said, well, I had done this, but I think I'll need to revisit that after the rain. I was using data as of yesterday. I'll take another look. And so it's this back and forth, and we try to come to an agreement on what the depiction will look like for that area. Ultimately, the map author's name is the one that's on the map. We're the ones that people call and that the media calls, so we make the final decision. The public, so we have feedback and input from our local experts, but then the public can also provide input via reporting of drought impacts. And there's ways that you can do that. You can tweet drought information using the hashtag Drought 2022. If you're a member of COCORAS, you can do condition monitoring reports. You can submit your rainfall data from COCORAS, and we're able to pull those condition monitoring reports into our GIS system and see what folks are saying there. And then the National Drought Mitigation Center has their own condition monitoring. It's a little more detailed than COCORA's system called Seymour. And you can find more about all of those on droughtimpacts.unl.edu. And then finally, you can contact your state climatologist. If you don't know who your state climatologist is, go ahead, shoot me an email. Tanya, if you can drop my email in the chat box, that'd be great. I can help you with any of this or point you to the right direction. So how do the authors make sense of all of the data and the impacts? Because it's a lot to look at, 150 maps plus emails from all of the states. When we've got a large part of the US being impacted by drought like we do now, we get a lot of input from our local experts, we get a lot of input from the public. So how do we make that determination? It'd be great if the data always showed the same thing, but it doesn't. Sometimes we get, conflicting data because we have different timescales of drought. And we interpret that by using what we call the convergence of evidence. And the convergence of evidence is a principle used in science that says when multiple sources of evidence or data agree, then the conclusions that we make can be very strong. So basically, when data from different sources and different timescales and different points in the water cycle tell the same story or show the same drought severity level, we can be, pretty confident in the color that we put on the map. So we start with the physical data. We look at that feedback from our local experts, and we look at the drought impacts. And what we're looking for is kind of ideally, we want that sweet spot where we have all of those telling us the same story. And so that ideally, that's what we want. A drought impact alone will not change the color of the map. It has to be supported by something else. So when we're looking at physical data, we have different sources of physical data, so that can support something. And we have the feedback and interpretation from local experts, but you can't just have one of these to do the drought severity category. Just like you can't use just precipitation to say it's a D4 drought. There has to be other evidence that is telling that story that's converging on that drought level. So this is kind of our timeline for making the map. One of the most important things is the data cutoff period. So for the map that was released this morning, the data cutoff was at 8 a.m. Eastern time. So any rain that fell at 8:01 is included on the next week's map. So this can make it really difficult and really complicated if we have rain falling over that cutoff period. But those totals on any measurement, it's what it looks like as of 8 a.m. the Tuesday right before the map is released. Let's see. So this is kind of what our drought monitor shift looks like. So usually we probably start, most of us I think probably start what we call spinning up the week before, is start to review the data, or even a couple weeks before, start following those conversations really closely. I know I usually spend Saturday and Sunday reading through all of the previous narratives for the past several months and looking at the maps and the change maps to get myself up to speed on what's happening. And then by Monday afternoon, I try and submit a draft for the entire US. Sometimes it's a little later than that, depending on how much drought is happening in the country and how much email I get. But I try and get something out by 3 o'clock my time, which is Central Time, to give the folks in the East a chance to look at it before the end of the day. Tuesday is just downright crazy. We typically submit multiple drafts. I start in the morning with incorporating anything that came in the morning or overnight. State calls are typically after that data cutoff time. And so I think the majority of our recommendations from states come in probably after 2 or 3 o'clock on Tuesday, which makes for a really late night, trying to reconcile what those state recommendations are with what our drafts show. On Wednesday, I try and have a near final draft out by noon. I think the input cutoff that I use, and it's about the same for most authors, is about 2 p.m. On Wednesdays, we don't like to have, if we haven't heard anything from a state team before, and especially if they haven't coordinated with surrounding states, and we don't have time to do that, you know, the later in the day it is, those might not get included until the next week, because we have to allow time for that process to work, that feedback process. That's such an important part of what we do as authors. Then the map is released on Thursday morning at 8:30, and by that point, I think most authors are exhausted. We've had probably more caffeine than you should have in a month at that time. But that's once that map is released, that's when the phone starts ringing with requests for interviews, with complaints about the map, with questions about the map. And so typically we spend our Thursday and our Friday on the phone and email doing follow-ups about the map. If you're the author again, that makes it easy. If it's at the end of your 2-week cycle, we make sure to send what we call a transition email to the next author saying, kind of, here's what I did, here are some areas that I'm watching for next week, just to try and help that process go as smoothly as possible. And even while this conversation is going on, the Drought Monitor authors themselves have their own separate listserv with just the 9 of us, and then some former authors too, like the director of our center who used to be an author, that we can ask questions to and get some feedback from the authors as well. And so there's a lot of support that way too. And then that's the final map. This is what today's map looked like. You can get it on the Drought Monitor website, droughtmonitor.unl.edu, but it's also tweeted out. I think each of the partner agencies has a map available, and many like sector groups have the map available as well. Education and outreach on the US Drought Monitor is important, as Tanya said, for our center. She and I work together on education and outreach, and we've helped create, or we have created tutorials and brochures, and we do webinars like this. We try and be transparent with the media. We try and respond to every call and every email that comes in. And, you know, once travel picks up, we'll probably start doing more in-person workshops. My email is here, dbathke2@unl.edu. The other 2 authors at the Drought Center are Brian Fuchs and Curtis Riganti. Brian gave last month's web meeting like this. Curtis is giving next month. If you have questions, you can contact any of us, and we're happy to answer that. And with that, I will I will take any questions. I see there's a few of them, and I'll do the best I can to answer them. And if we run out of time, Tanya will save the chat box and I will try and follow up with everyone.
Do you want to start with this one I have in the chat box? Is that cool?
So the question, is it the one from Alyssa?
Yes, yes.
Or is it sooner than that?
Nope, it's from Melissa.
Okay, so Alyssa Klein from Agriculture and Agri-Food Canada. She works with the Canadian Drought Monitor. And she says, I'm curious, how much would you say local regional geographies, soil type, climatology, et cetera, play in the process that the USDM takes when it comes to drought monitoring? And I would say it's most of, we use point data, but we also use some satellite-based data. So some of that is how it's worked into a specific product, and the resolution of some of those products can be fairly big. I would say where it most comes into play is through our local experts who help us out in interpreting the data. We can't be everywhere. We can't look outside everyone's window. We don't know I personally don't know the soil types in every county. There's probably someone out there who does, but it's not me. And so we have, that's what our expert groups are for. We have some soil scientists on there who will chime in and say, well, soils in this region typically do blah, 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 and help us out that way. So I guess that's my answer to that. I hope that answers your question. If it doesn't, let me know. I see another new.
I don't see any other ones in the chat box, but if anybody has a question, you can unmute and ask Deborah.
Or type it in.
Or type it in, yeah. You might have just answered every question that anyone had.
I'm sure that I did such an excellent job that I cleared up every single question that anyone could possibly have.
Okay.
Okay, there we go. How's drought monitoring changed in the last few decades? You know, thank you for that question. And if you're, I guess, geeky like me about some of this stuff, you can go through and look at some of the old, the earlier drought monitor maps that started in 2000, and you can see that the resolution has changed because we have more and more data at higher resolution. And so that has helped us increase, you know, the detail that you see on the map. And the drought monitor today is not the same drought monitor from 2000. There are many more products available to it. And, you know, if we have not done that, we don't have time to go back and reanalyze everything. But it would look different. And, you know, and when we look at, so we have more data, we have it at a higher resolution, and then the period of record that we're looking at is 20 years longer too. And so every drought index, when we look at percentiles, it just gets added onto it. And so what was a D4 back in 2002 with 20 more years of data might not be a D4 anymore. It might not be in the driest or warmest in the period of record.